The edge of the universe was supposed to be the end, a final boundary, a quiet wall where everything fades into darkness. But that is not what we found. When the Hubble Space Telescope pushed its vision deeper than ever before, it revealed something that should not exist, not according to everything we thought we understood, not according to everything we thought we understood, not according to the laws that have guided modern cosmology for decades. Galaxies appeared too early, too massive, too organized, as if the universe skipped steps, as if something accelerated the process beyond what physics allows. The closer we look to the beginning, the more reality itself begins to feel unstable. In this video, you will uncover what Hubble actually saw at the farthest limits of space. You will understand why these discoveries shocked scientists across the world. You will see how observations from the deepest regions of the cosmos are forcing experts to question the timeline of the universe itself. And by the end, you will face a deeper question that most people never even consider. Are we completely misunderstanding how the universe works? To understand why this is so unsettling, we need to start with what Hubble was built to do. The Hubble Space Telescope was launched with a simple but powerful goal: look farther than any telescope before it, capture light that has traveled across billions of years, reveal the structure of the universe on the largest possible scale. Unlike telescopes on Earth, Hubble orbits above the atmosphere. There is no distortion from air, no interference from weather. It sees space with extraordinary clarity. This allowed scientists to turn it toward areas of the sky that appeared completely empty. No stars, no visible galaxies, just darkness. That decision changed everything. When Hubble stared into what looked like nothing, it did not find emptiness. It found thousands of galaxies packed into a tiny region of space, each one containing billions of stars, each one existing so far away that its light began traveling long before Earth even formed. This was not just a discovery. This was a shift in perspective. The universe was not sparse and simple. It was dense, active, and filled with structure, even in places that seemed completely empty. But the real shock came when scientists realized what they were actually looking at. Because looking far into space is not just about distance, it is about time. Light does not travel instantly, it moves at a fixed speed. And this means that when Hubble captures light from distant galaxies, it is not seeing them as they are now, it is seeing them as they were in the past, sometimes billions of years in the past. So when Hubble looks deeper, it looks further back in time, closer to the beginning of everything, closer to the moment after the Big Bang. Scientists expected that as they approached this early era, the universe would look very different, simpler, less structured, more chaotic. The early universe was supposed to be a rough place. Matter was still coming together. Gravity was slowly pulling gas into clumps. Small, irregular galaxies were just beginning to form, nothing large, nothing organized, nothing mature. That was the expectation. The idea is called the observable universe. It is not the entire universe, it is the part we can see. The part whose light has had enough time to reach us since the beginning. There is a limit to this, a boundary not in space, but in time. Beyond a certain distance, light has not had enough time to arrive yet, so it remains invisible to us. This creates a kind of horizon, not a physical edge, not a wall, but a limit to what can be observed. The farther out we look, the closer we get to that limit, and near that limit, everything should become more primitive, more raw, more unfinished. But that is not what Hubble found. Instead of small, chaotic structures, it revealed galaxies that already looked developed. Some were surprisingly large. Some showed signs of complex structure. Some appeared to be forming stars at rates far higher than expected. This was deeply confusing. According to existing models, there simply was not enough time for such galaxies to form. The universe should not have evolved that quickly. The timeline did not allow it. It was like opening a history book to the first chapter and finding fully built cities already standing. Something was off. At first, scientists questioned the data. Was there an error? Was Hubble misinterpreting the light? Were distances being calculated incorrectly? But the more data they gathered, the clearer the picture became. The observations were real, the galaxies were there, and they did not fit. This created a growing tension in cosmology. On one side, there were well-tested theories, models that explained how the universe evolved from simple beginnings to the complex structure we see today. These models had been refined over decades, supported by observations, trusted by the scientific community. On the other side, there was direct evidence from one of the most powerful instruments ever built, and the two did not agree. This is where the mystery begins. If the universe formed differently than expected, then something fundamental may be missing from our understanding. Perhaps the early universe behaved in ways that current physics cannot fully explain. Perhaps unseen forces played a larger role. Perhaps the timeline itself needs to be rewritten. Or perhaps something even more unsettling is true. The deeper we look into the universe, the more we realize that our picture of reality might be incomplete. Hubble was not supposed to break our understanding. It was supposed to confirm it, to refine it, to add detail to an already solid framework. Instead, it exposed cracks, and those cracks lead to a question that grows more uncomfortable the deeper we go. Are we seeing the universe as it truly is, or just a simplified version shaped by our limited perspective? Because at the edge of what we can observe, the rules start to blur, and what lies beyond that edge may not follow the patterns we expect. Welcome to the channel. If you want to explore the deepest mysteries of space and uncover the truths that challenge everything we think we know, make sure to subscribe and stay with us until the end. When people hear the phrase edge of the universe, it sounds like a boundary, a final border where space simply stops. But that is not how the universe works. There is no wall out there, no cliff, no sudden drop into nothingness. The universe does not have a physical edge. It does not end like a room or a box. Instead, what we call the edge is something very different. It is a limit created by time. This is known as the observable universe. Right? It is everything we are able to see from Earth. Not because that is all that exists, but because that is all the light that has had enough time to reach us. Light travels at a fixed speed. Nothing moves faster. This creates a natural boundary. If a galaxy is so far away that its light has not reached us yet, then it remains invisible. Not because it is not there, but because its signal is still on the way. So when scientists talk about the edge, they are talking about the farthest distance. We can observe the oldest light we can detect, a horizon built from time itself. And this is where things become strange. Looking deeper into space is not just looking farther away, it is looking backward. Every star, every galaxy, every faint point of light is a message from the past. Some of that light began its journey billions of years ago, long before Earth existed, long before the sun even formed. This means that powerful telescopes are not just tools for seeing distant objects. They are time machines. The farther we look, the earlier we see the universe. And scientists have a way to measure just how far back they are looking. It is called redshift. As the universe expands, light traveling through it gets stretched. Its wavelength becomes longer. It shifts toward the red end of the spectrum. The greater the shift, the farther the light has traveled, and the older it is. So when scientists detect a galaxy with a high redshift, they know they are seeing it as it existed in the very early universe, close to the beginning, close to the aftermath of the Big Bang. And according to everything we believed, that early universe should look very simple. It should be chaotic, hot, filled with scattered gas and radiation. Structure should barely exist. Gravity would still be pulling matter together, slowly forming the first small clumps that would one day become galaxies. These early galaxies were expected to be tiny, irregular, and messy. They should look unfinished, like rough drafts of the massive galaxies we see today. There should be no large, well-formed systems, no organized structures, no signs of rapid growth. Time was simply too short. The universe needed hundreds of millions, even billions of years to build complexity. That was the model. That was the timeline. So as telescopes like the Hubble Space Telescope looked deeper and deeper, scientists expected to see this simplicity, a gradual transition from chaos to order, a clear story of evolution written across the sky. But the deeper the observations went, the more that story began to break apart. Scientists made a decision that seemed almost pointless at first. They pointed the Hubble Space Telescope toward a region of the sky that looked completely empty, no bright stars, no visible galaxies, just darkness. They let the telescope stare at that patch for days. Then for longer, they collected every faint trace of light that reached the detector. This method became known as a deep field observation. It is not about scanning large areas. It is about focusing on one tiny spot and pulling out the faintest signals possible. What came back was not empty. It was overwhelming. That small patch of darkness exploded into view. Thousands of galaxies appeared where nothing had been seen before, each one a massive system of stars, gas, and dust, each one shining across unimaginable distances. The region they studied was so small that it would look like a grain of sand held at arm's length. Yet within that tiny space, there were more galaxies than anyone expected. This changed how scientists saw the universe. Empty space was not empty at all. It was filled with distant galaxies that were simply too faint to detect before. But the real shock was not the number of galaxies. It was their age. The light from these galaxies had traveled for billions of years. Some of it began its journey when the universe was still very young, when structure was just beginning to form, when everything should still be in its early stages. This meant that Hubble was not just seeing distant galaxies, it was seeing ancient ones, galaxies that existed close to the beginning of time. And they did not look the way they were supposed to. Instead of small, faint, irregular shapes, many of these galaxies appeared brand, more developed than expected. Some showed signs of intense star formation. Some seemed larger than models predicted for that era. The deeper Hubble looked, the more this pattern continued. Galaxies were appearing earlier than they should, not just a few, many. This created a growing sense of tension, because according to existing theories, the universe needed time to build complexity. Gravity had to pull matter together, stars had to form, galaxies had to grow slowly through mergers and accumulation. That process should take a long time, yet here were galaxies that seemed to skip ahead. Some were forming stars at extreme rates, far beyond what was expected for such an early period. Others appeared surprisingly bright, suggesting large amounts of mass already in place. This was not a quiet, simple, early universe. It was active, crowded, full of energy. In simple terms, the universe looked busy too soon. That single observation forced scientists to reconsider their assumptions. Either these galaxies were somehow different from what they appeared to be, or the timeline of cosmic evolution was not as smooth and gradual as once believed. The deeper the images went, the harder it became to ignore the pattern. Every new deep field added more evidence, more galaxies, more early activity, more signs that something was not lining up. And with each discovery, a quiet question began to grow louder. If the universe looked this complex so early, then how did it get there so fast? As scientists studied these distant galaxies more closely, the numbers became impossible to ignore. Some of these systems existed just a few 100 million years after the Big Bang. In cosmic terms, that is almost nothing. A brief moment after the beginning, yet they were not small. They were not simple. They were massive. These galaxies contained billions of stars. Some showed clear struct, Urus, not perfect spirals like the Milky Way, but far more organized than expected. There were signs of dense regions, signs of rapid star formation, signs of growth that should take far longer. According to standard models, galaxies begin as small clumps of gas and dark matter. Gravity slowly pulls material together. Over time, these clumps merge, they grow, they evolve into larger systems. This process is slow, it depends on time and interaction, but the galaxies seen by the Hubble Space Telescope did not follow that timeline. They looked like they had skipped steps. Some of them were forming stars at extreme rates, hundreds of times faster than galaxies like the Milky Way. This is known as a starburst phase. It is intense, violent, short-lived, but seeing it so early raised serious questions. Where did all the material come from? How did gravity pull it together so quickly? There simply was not enough time. Even more puzzling, some of these galaxies appeared surprisingly bright. Brightness often means mass. More stars mean more light. But building that many stars requires vast amounts of gas and time to convert that gas into energy through nuclear fusion. That timeline did not match what was observed. In some cases, scientists found galaxies that seemed almost fully assembled. Not complete, but far beyond what should exist at that stage. It was like finding a nearly finished structure where only the foundation should exist. This created a direct conflict with galaxy formation models. These models are based on well-tested physics. Gravity, dark matter, gas dynamics, they have successfully explained much of the universe we see today. But here at the earliest times, they began to fail. The predictions no longer matched reality. At first, researchers considered simpler explanations. Perhaps the distances were being miscalculated, perhaps the brightness was misleading. Perhaps these objects were not galaxies at all, but something else. But as more data came in, the pattern held. Multiple observations, different regions of the sky, consistent results. The universe was forming large active galaxies far earlier than expected. Another surprising detail made the mystery even deeper. Some of these early galaxies already contained heavier elements like carbon and oxygen. These are not created in the beginning. They are formed inside stars and spread through supernova explosions. This means that at least one generation of stars had already lived and died inside these galaxies. That takes time, more time than the early universe should allow. So now the problem was not just about galaxy size or brightness, it was about chemical history, these galaxies had already gone through cycles of star formation and destruction. They had a past, and that past seemed too long for their age. All of this pointed to one uncomfortable idea. The early universe may not have evolved the way scientists expected. The rules may still be correct. The physics may still hold. But something about the pace, the conditions, or the hidden components of the universe might be different. Something may be missing from the picture. And if that is true, then the entire story of how the universe grew from simplicity to complexity may need to be rewritten. For decades, scientists believed they understood the timeline of the universe. It was built on a simple idea. Structure formed slowly. After the Big Bang, the universe began as a hot, dense state. Then it expanded, it cooled. Tiny fluctuations in matter started to grow under gravity. Over time, these small clumps pulled in more material. They merged. They became larger systems. This gradual process is known as hierarchical structure formation. Small objects form first. Large ones come later. That idea has been the backbone of modern cosmology. It explains how galaxies, clusters, and large-scale structures developed across billions of years. It matches many observations. It has been tested and refined again and again. But the data from the Hubble Space Telescope is pushing against that foundation because the early universe does not look slow. It looks fast, too fast. Galaxies appear earlier than expected. They grow larger in less time. They form stars at extreme rates. All of this suggests that something is accelerating the process. It is as if the universe started building complex structures almost immediately instead of taking its time. This creates a serious tension. If the timeline is correct, then the observations should not exist. If the observations are correct, then the timeline must be incomplete. One possibility is that the early universe behaved differently. The laws of physics we use today are based on experiments and observations in the current universe, but conditions near the beginning were far more extreme. Temperatures were higher, densities were greater, interactions between particles were more intense. It is possible that under those conditions, processes happened more quickly. Gas could have cooled faster. Gravity could have pulled matter together more efficiently. Star formation could have been more aggressive. Another possibility involves dark matter. Dark matter is an invisible form of matter that does not emit light, but exerts gravity. It plays a major role in structure formation. It acts like a scaffold pulling normal matter into place. If dark matter behaved differently in the early universe, it could explain the rapid growth of galaxies. Perhaps it clumped more quickly. Perhaps its distribution was not as smooth as models assume. There are even ideas that new forms of dark matter or unknown particles could exist. These could influence how structures form at early times. Some scientists have also explored the role of dark energy, although it is usually linked to the expansion of the universe at later times. If its effects were different in the past, it could change how quickly matter gathered. There are also more radical ideas. Some suggest that the initial conditions after the Big Bang were not as simple as assumed. Slight differences in density could have led to rapid growth in certain regions. Others question whether current measurements of distance and time are fully accurate at extreme scales. Even small errors could create large shifts in interpretation. All of these possibilities point to the same conclusion: something is missing. The standard model of cosmology is powerful, but it may not be complete. The early universe might contain physics that we have not yet discovered, processes that do not show up in the present day. This forces scientists into a difficult position. They must question assumptions that have stood for decades. They must test new ideas. They must look for evidence that can confirm or reject these possibilities. And as more data comes in, especially from newer instruments, the pressure only increases. Because if the timeline is wrong, then the story of the universe is not just incomplete. It is fundamentally different from what we thought. The deeper we look into the universe, the less stable our understanding becomes. At first, science feels solid. There are equations, models, predictions that match what we see. It creates a sense of control, a belief that the universe follows clear rules that can be understood step by step. But at extreme distances, that certainty begins to fade. The observations from the Hubble Space Telescope do not just add new details. They challenge the structure of the story itself. They expose gaps. They raise questions that do not have simple answers. RRS galaxies appear too early, too large, too active. Each discovery pushes against the limits of what current physics can explain, and this is not the first time this has happened. In the past, major breakthroughs in science often began with small inconsistencies, tiny mismatches between theory and observation. Over time, those mismatches grew. They forced scientists to rethink everything. The discovery of dark matter came from motions that did not make sense. The expansion of the universe revealed that space itself is changing. Even the idea of the Big Bang began as a controversial explanation for unexpected data. Now, something similar may be happening again. There are hints that the current model is incomplete, not entirely wrong, but missing key pieces. Pieces that only reveal themselves under extreme conditions. One of the most unsettling ideas is that reality at cosmic scales may not behave in ways that feel intuitive. Human intuition is built on everyday experience. Gravity pulls objects down. Time moves forward at a steady pace because it leads to effect in a predictable way, but the universe does not have to follow those expectations. At large scales and early times, different rules can dominate. Quantum effects, extreme gravity, and unknown interactions may shape reality in ways that are difficult to visualize. Even time itself becomes complicated. When looking across billions of light years, past and present begin to overlap. The sky becomes a layered record of different eras, all visible at once. This makes interpretation harder. A galaxy seen today is not truly present. It is a memory, a signal from the past. And that signal can be distorted, stretched, altered by the expansion of space. So the deeper we look, the more careful we must be. Not everything is as it appears. There's also the limit of technology. Even the most advanced instruments abound. Aries, sensitivity, resolution, noise. At extreme distances, signals become faint, data becomes uncertain. Small errors can lead to large conclusions. This means that part of the mystery may come from the edge of what we can measure. But even when accounting for these limits, the pattern remains. The early universe refuses to behave as expected. This leads to a deeper realization. The edge we are approaching may not be a physical boundary at all. It may be a boundary of understanding. A point where current knowledge begins to break down. Beyond that point, the rules may change, not because the universe is incomplete, but because our description of it is incomplete. This shifts the meaning of exploration. It is no longer just about looking farther into space. It is about pushing against the limits of human knowledge, testing ideas that once seemed certain, accepting that some answers may lead to even deeper questions. And as we continue to observe, as instruments become more powerful and as data becomes more precise, that boundary does not disappear. It moves, and just beyond it, the universe waits not as a solved puzzle, but as something far more complex than we are ready to fully understand. The Hubble Space Telescope was built to bring clarity, to sharpen our view of the universe, to confirm the story we believed was already taking shape. But instead, it revealed something far more unsettling. It showed us that the deeper we look, the less complete our understanding becomes. Those distant galaxies were not just points of light. They were evidence that the early universe may have been more complex, more active, and more unpredictable than our models ever allowed. Structures forming too fast, stars igniting too early, systems evolving in ways that do not fit the timeline. This is not a small error, it is a signal that something fundamental may be missing. And every time we push farther, every time we collect more data, the mystery does not fade, it grows. New observations do not close the gap, they widen it. That is the strange reality of exploring the universe. Each answer opens the door to deeper questions. Each discovery challenges what came before. The picture becomes richer, but also more uncertain. In a way, the universe is not just expanding through space, our confusion about it is expanding too. And that might be the most honest truth science can offer, not certainty, but a constant search. A process that moves forward by questioning itself. There's still so much we do not understand, and that is exactly why this journey matters. If this kind of mystery fascinates you, if you want to keep exploring the deepest questions about reality and space, take a moment to like the video and subscribe to the channel. There's much more to uncover, and the next discovery might change everything again.